Okay, let's start. Hi, everyone. Welcome to this August webinar. Today, I'm going to talk about testability. And testability is sort of a cross between two worlds, the development world, the developers world, and the testers world. And I'm going to talk about at the end of who's responsible for testability. I'm going to talk about how we perceive testability and give examples, both in code and in drawings. And I hope it's going to be beneficial for you. My name is Gil. I'm a trainer and a consultant for all things relating to better software. So I work with the testers, developers, product people, agile people, people who play with gadgets. I'm the author of 2 books, Everyday Unit Testing, Everyday Spring Testing. And you can get in touch with me with these things on the screen. Most of the time I start with the end in mind. What do we want? We want code that works over and over again. Today we're going to talk about the works part. How do we know that code works? We test it. But in order to test it, we need for it to be testable, right? Testing gives us confidence that what we're building actually works and will probably work in the next phase. It could be in production, what we probably want. But it also, if it's working on my machine, it gives me confidence that it will work at the team level, at the CI level, and so on. We need to also keep in mind about the over and over again part, that it's not a one-time thing. It's not like we design something, it's going to be perfect. No, we're going to go into the code and change it. And we want the feedback of tests to be there to help us along the way. I want to say that the things I'm going to talk about today kind of spread out in different courses that I give in clean code, in unit testing, in AI automation testing workshops. So if you're interested in one of those, give me a shout out. So I've been in a couple of conversations when people just said, well, this code is untestable. Give you a hint, they did not write this code, but that's okay. Usually code is not really testable, untestable. But there is kind of an implication when you say, well, this is untestable. And that means that we're not going to even try to test it. That's a problem because, like I said, what we are after is something that we know that works. And if we kind of say that we're not going to test it because it is untestable, we're kind of ranking down our confidence. If things are testable, the chances are we're going to try and test them. We can also try to ignore the way systems are built affect their testability, kind of say that this is black box completely, but this is not true. A lot of the time, testing really, or the level of testing that we can do and the results that we can achieve comes from the way the code works or is built, the way systems are connected, and so on. So is something really untestable? No, you usually test it's we kind of look at something and we start the calculations in our mind. How much time it will take, what kind of effort do we need to do in order to test these kinds of scenarios, what kind of skills we need. Maybe we don't have the skills to do it, so we don't even know how to do this. So it's not a question of maybe it's untestable for us today, but it's not going to be untestable for us in like 6 months from now. And it comes down to a lot of the things that these 3 things are okay, but the 4th one is really the one that really impacts the way we think about testability. Motivation. Would we like to actually do it or not? So when we look at code, it is going to be very subjective. Different people with different motivations, different skill sets, will look at this differently, and will then decide, well, it is going to be complex, but maybe we can do it, or maybe it's not. It depends on many things. I'm going to show examples today in Java, but you think about even the way code is written, the language that it's written has an implication of how hard it is or easy it is to test, or how we perceive how hard it is to test. Like mocking private methods in Java is hard if you don't know how to do it. But mocking or patching in Python of private method is easy as patching like public methods. So the language, the patterns we use, our history. If we wrote the code, we know how to test it, obviously, right? Because if it's untestable, somebody else has wrote it. But if it's this kind of code has gone through 10 hands or 10 keyboards, first we can sense that. Second, we can probably know that. And it's going to impact, you can see that in the code that things are written in different languages, and therefore our perception of how testable it is kind of low. And like I said, also, it's up to, we need different techniques that we're going to employ when we're going to do testing. And sometimes we don't know what to do, or we know what to do, but we're new to that. Or sometimes it's very easy because there's already a template for the test, like there's a test for scenario one. If there is a test for the first one, for the if part, it's probably not going to be that hard to do for the else part. So a lot of these things come into question when we're trying to like rank or evaluate testability. So what makes things testable? So try to like think about and like cut it down into parts of what makes things more testable and less testable. And I gave them very strange names. And these are the names for. The first one is the operability. How easy it is or how hard it is. Everything is going to be how easy how hard it is, because it's not a whether or if. To run this part of the system or run the code. If it's going to be like a very simple example, if I'm writing a unit test and I'm trying to run a private method, it's going to be a bit more hard to do than running a public method. It can be a lot more than that, but like if I'm running a logic that is inside a server and under an API, and all I have is this API, it's going to be hard to like thread the needle to get to this part of the code that I need. So obviously there's going to be levels, but how easy it is and how hard it is to run this part of the code that I am interested in is going to be a part of that. The second part is the second part of testing. If we're doing something to a system, to code or something, we need to be able to see what kind of impact that operation is done. Like if we're doing some kind, operating some kind of code, we want to write an assert to make sure that we observe the change. And sometimes it's easy, but sometimes it's not that easy to observe the result. And we might need to do extra things in order to see that. Example we'll see later is that if we're, for example, if we save data, when we can't get to that data, how do we know that these things worked? We'll see an example. The third part is, I called it controllability because I was looking for a very complex word after the first two. And that is not about the code itself. It's about the system or environment that it runs in. Because that takes effort and skill and motivation too. Because if you, for example, run with a database that you need to load up with different sets of data, and you need to prepare this kind of data, and then you need to clean up after this test because we're running against it the next day, that requires a lot of effort. And we need to control the environment and then the right dependencies, the right JDK, whatever, the right Windows version. We need to control that in order for our test to give us confidence. And if it comes down to, like, if I'm just going to run this test anywhere and it would work, we're talking about probably unit tests, API tests, system tests, end-to-end tests require a lot more than that. And this translates to how we perceive how easy or how much effort and skill and so on it takes in order to write these tests. By the way, I'm talking about automated tests, but you can translate that everything like that to manual tests as well. The final thing, reproducibility, is our ability. Again, why are we running? Why are we doing tests? We run tests in order to see results that gives us confidence. But the over and over again part means that we expect the same results over and over again, unless there's a problem and so on. So reproducibility means that we need to take into account things that are not synchronic or will be delayed or timeouts, and everybody's coming from the microservice world knows that we can't control everything there. So if controllability means that I'm going to do everything in order to set up the operation, maybe it's not enough because I need to control threads or parallel processes inside our code and tests in order to make sure that these things actually be reproducible. And again, think about it. This impacts the way we perceive how easy it is or how hard it is to write these kind of tests. There's probably five or six, but I haven't gotten to them yet. But 4 is enough for now. So let's take a look at a couple of examples of things that we perceive as affecting testability and what we can do about them, because I think most of us agree that better testability is good for us. And the question is, well, how do we get there? So I'm going to show a couple of examples, both at the code level and up from that. And the idea is that developers can look at that and say, well, we know the patterns, therefore we can write the code in a certain way in order to make it more testable. And the testers, apart from seeing these examples, can have a decent conversation with the developers in order to maintain this kind of testability. Because again, I'm assuming everybody agrees that better testability is good, and it's good for everyone. It's not just like good for the developers. It's good for everyone, because at the end we'll have a product that is of better quality. So let's look at an example. The first one I was going to talk about is a very low level, and I mentioned that before, visibility in terms of public methods and private methods and how we perceive testing them. So let me put Marty McFly on the back burner and switch to IntelliJ. So my examples today will be something that I conceived like a string container. It's going to be a class that holds a string and has a method called find occurrences that will go over it, and mainly the algorithm about it will be like inside this. It's counting how many occurrences of the substring is going to be in there. Note that it doesn't always do that, but it only works for valid strings. Of course, valid strings starts with GIL, not eagle. Yeah, as most valid strings do. So this is an example for where the logic that I want to test is inside a private method. And this is more about operability, right? Because I'm interested in running this code, but I have to run it through here, usually, because that's a public method. But in order to run it, I have to supply something that is valid, because I can't run it on an invalid string. So if this thing is in the same class, I'll probably where are my tests. So what is the same class? Public calls a private method. How do the tests look like? So if I'm running an invalid string, doesn't start with GIL, I won't get there. So find all occurrences, the public method will not call the private method. It will work for a valid string, starting with GIL. And then I can say, well, the logic in the private method works. But that's not the only way to do it, right? Because Java has a reflection. And different languages have ability to run private methods as well. So let me get, why is this here? Yeah. So if you look at it, like I used reflection here, find the method, the private one, set accessible to true. I need to do this in Java, and then I'm creating this. And when I run it, I run the internal, the private method without changing the code. So again, what is this kind of example? We kind of think in a way that testing private method is impossible unless unless I know a way to do it, like a reflection here. But refactoring is also a possibility. Changing the code is an option. So let's look at an example. So in this string container, I just created a finder class that has, and move this logic there. And when it's here, it's kind of a public thing. It could be like an internal package or something like that. Depends on the language you are using. But once it's there, we can consider it. Well, it's become like a public thing. If it's a public thing, no problem. I can call it the create tests for the finder class and therefore test that. So when we look at, is it possible to call some code? We need to be aware that there are ways to do it. And there's always the final one, which is changing the code. Now, usually when I'm saying to people, you have a private method, change it into public, I get screamed at, I got used to that, but that's okay. Remember, code is just code, just bits. Did the originator of this code think that this is going to be private and therefore it should not be called? No. Usually the problem in this kind of problem is that it started writing a public method and then it became too long, so they extracted that into a private method. But it doesn't matter how we got here. If it makes us sleep better at night to know that this kind of code works, we want to test it. If we want to test it, yes, maybe changing it, which increases the testability, will make us write these tests first, and then sleep better at night knowing that this thing is covered. Let's get back to Marty and talk about mockability and mocking. So we look at code, and we'll see an example in a minute. And the way when we're talking about mocking, is basically something that we do in order to get isolation. We're interested in testing some bit of code that some other bit of code is giving us a nudge and saying, nah, we don't do it here. And the way we get rid of this nana code is by mocking it. And there are different ways to do this. And the way the code is written also impacts how we perceive it is easy or not to do it. So let's go to Mr. Code. Okay. And we usually think about dependency injection and this kind of thing. So this would be our examples for now. Let me close everything else. Okay. So a string container now basically calls a method on Finder. And Finder looks like this. It's under construction. So that this will be our dependency that creates a problem for testing the real code, which is here. Now, there are two problems here. First of all, is the crashing thing. Now, and the second thing is happening here. We usually say about this kind of code that the string container is coupled to the Finder class. And that means that whenever the Finder class changes, string container needs to change as well. That's not the main problem, though. The problem is that we can't replace Finder. You can't mock it, right? So let's look at what happens when, if there's no DI, like this kind of code, the only thing I can do is crash. I call the method, it will call the internal method, boom, okay. If the code was written differently, like this, so I'm passing along the Finder, this is a bit different because the way Java works, if Finder is not a final class, and in our case it isn't, it's the same Finder as before, okay, same crash, that means we can mock it. And whenever this, we can replace this the behavior from Finder currencies to do something. I took the easy way, doing it with Mockito. So I'm creating a mock for Finder, setting a behavior on it to return something not crash, and that's basically it. So we usually think about, well, if it's possible to inject it in a certain way, and a certain way means either through this, or if we in Java, if we're working with Spring or dependency injection framework, we can just do it through there. If we have a factory, we can do it through there. We can do this, but until years ago, not too many years ago, it was not possible to mock our constructor the way it was here. This is the original one. So this was not this was not easy to mock, and therefore we needed to change that. That changed with Mockito 3.9. So having the right tool, we can write a test like this. It's a bit clunky, but what happens is that when we're using try and mock construction of Finder, that means that everything that is a new Finder in our block will be mocked. Excellent. That syntax is create a mock for this block and call the prepare Finder, which runs this method, the when then return. So we set up the mock and everything's okay. So having the right tool for the job changes testability. And if we thought about it, well, this is impossible without changing, without dependency injection up until Mockito 3.9. It changed then. Actually, it was possible to do this before Mockito 3.9 because there were other tools like Power Mockito in the Java space that in JMockit that could do that. Same things in C#, and obviously, if you have the same problems in different languages, they're kind of solved. is in Python. It's very easy to do that. So languages and tools impact our thinking about testability. And also with the right tools, we need to change less. Couple of more examples around this. So statics, right? You couldn't mock statics. Statics and singletons are evil. They are a curse upon the land of development. Well, it was until they were a curse because they kind of were impossible to mock in a certain way. So, but there are things that you can do. So, for example, here I call defined occurrences, which is a static method, right? So this time it's a static method, not an instance method, but I could change the code. For example, I could change finder to hold something to return unless I set it. I've done this before. Okay, so change the code for testability. Is that bad? No, testability is up there. So a test for that will look like this. So I'm setting something to return, and then everything I do a round pass around the problematic area, and kind of mocked it with changes. What else? Obviously, with Mockito, you can, since 3.5, something very similar to the mock constructor. It's called mock static. And when you can use, you can now mock static methods. And this, it's weird because we used to think about, well, Mockito doesn't do that, and there's a reason it didn't do it, because the language didn't allow it, right? How did Mockito work, and it still works for instance methods? It derives a type and at runtime and sets some behavior on it. And it couldn't do it this way for statics and constructors. Still doesn't do it for privates. Because you could not do it. But first of all, you could change the code, and then suddenly Mockito could do it. So let's talk about private methods, which Mockito still doesn't do. Don't know why. I think it's a design decision not to support mocking private methods, which I think is kind of stupid. So this is like our original one. This is where we start thinking about partial mocking. We want to test this code, but we have a private method that creates the problem for us, and we want to mock that. Obviously, this could be like, it creates problem for us. It could be like delays. It could be like calling a service, different million things. We want to go around this one. So what do we do? Well, Mockito doesn't mock private methods, but he can mock protected methods. So I can go to our string container and change that into protected, and everything works. I can change it into public, but like I said, people like to scream at me when I suggest that. They kind of get this, the pill goes down better with protected. So you can do this, and with Mockito, the test will look like this. And it's possible to mock private methods. I'm using a spy here to do this for partial mocking. There's another way. If it's protected, I don't need Mockito. I can use a testable object. So testable object patterns, basically you define them in the test. They derive from what you actually want to partially mock. And then you override what you actually want. And in the test, you use these. I'm not using the real object because this one will break, but I am using the parts of it that actually work. And this one's the part with the problem is gone away. So the testable object pattern is something that I know exists because I learned and used it and so on. And that means that my perspective about testability is a lot different than people who don't understand what to do with a private method that sits inside an ugly class and don't know what to do about it. And they would probably say, well, this is untestable. It is not. It's like, if I want to make sure the other code works, I need to know stuff and be able to do stuff and understand the risks of changing stuff. But it is testable, more testable. Okay, that was mocks. Let's talk about coupling. So we saw already at the code level, like when we created the finder inside it, like we said the code is coupled. But coupling doesn't have to be like this. It could be at a higher level as well. So I'm going to show you an example of something, a bit of code, our string container. Only this time it doesn't say it just float around as a unit. It listens on a Kafka stream with a topic that answers, and if it's the right topic, it gets the data from it, does its string container things, and then send the result out through another Kafka queue. So let's see how code, the way it's written for that, can impact our ability to test it. Right, let's close everything and go here. So this is a Kafka string container. It has a lot of setup things here to set up all the Kafka queues, the consumer, the producer, and has a while loop that extracts the data, that pulls the data and extracts the data, and then finally does the string container thing, which is basically here, all within inside this class. And you look at this class and say, does everything. And you say, well, in order to test this, I have a problem because I need to set up everything. If you look at it from a black box kind of a point of view, you need to set up a stream here, need to set up a stream here, send a message, and hopefully it will get to the right thing, and hopefully it will be sent. I'm going to listen at the other end to this. We look about testing this kind of thing. I'm saying, well, highly untestable. We don't really want to do it. We can do it, like with the right skills and right knowledge, enough motivation, we will do it. But we probably don't want to do this. And just because it looks like this, if it looked differently, like if we have a receiver that all it does like pulls the data, and it have a sender that sends the data out, and then we're left with a string container that just does string container things, then it's a bit different, right? Because we can kind of rely on the receiver and the sender working together, and maybe test them separately, maybe test the string container as a unit test. Our perception of this thing becomes more testable than before. I can actually write these things. Let's look at it. I didn't do the O1 because I didn't have the motivation to write a test for that. So if I do that, I can actually mock the sender. And this is kind of interesting because this time I don't have a result, because the result is passed to another system, right? So I need to say this is like interaction-based testing. I need to see that what is sent is correct. So this is what I do here. I create a mock and then make sure that it is sent the right thing. But I can take it a dip. Another step further. If the code was thinking, we were thinking about it is as an architecture of ports and adapters. So I'm working with adapters and facades and not directly with the right sender. And it may look like this. So I'll have the message receiver, which listens to the Kafka stream, and it doesn't know anything about who's doing the processing because that's an interface. And I have the string container, which is a processor, and it has a process method that it implements, and it doesn't know the sender because the sender is also another interface. And then we have the current sender, working with these kind of interfaces with the adapters in place, we perceive that as a lot more testable. So we can write things like same thing, but it even looks simpler than that, because now the sender is passed as an interface directly. Regular vanilla flavor mojito, everybody loves it. So the way code is arranged or rearranged impacts the way we see testability. So we're talking now about not just the code, it's design, it's architecture, how services talk to each other. And when it's easy, it's easy. When it's hard, we see these things as less testable. More about visibility. So I'm leaving the code behind. Let's talk about APIs. Can we see what we want to see, and how much effort is there? So let's say we have an API, post API. This is the body that we're sending. This is the payload. Topic, date, start, date. That's scheduling API, for example. And all it does is return a 201. So does it work? Remember, we talked about observability. Can we see that there were changes? Well, how do I know this work? Well, I can rely on the 201, maybe, but probably not. I will probably need something else. I want to see that data, that a meeting was created. How do I do that? It doesn't create, it doesn't give me an ID. So that's a problem. And assuming I have a getter, get meeting. So now maybe I have a get all meetings API. And then I have to go through all the meetings, look for the things that I entered, and make sure that it is correctly to whatever. And if I don't have to have this kind of APIs into the system, I need to go to look in the database or use other tools, read logs, whatever you do on weekends. It creates a problem just because there's no insight into the system. If it only returned this, for example, so we get a status of 201, but it does also return an ID and some kind of feedback that I got this kind of thing, we perceive this as more testable. It's not that I won't look at the get, but I can get to the get. I can actually invoke a get method with the ID. I can look for it in the get all meetings and look at the ID and see that things are the same there or not. So our ability to test the API, basically we're talking about the feature, becomes much more easy to do. Data access, I'm kind of going back and forth here, but how do I know that data has changed? And like with the API, there was an example of like, how do I get to the data? So here's a very simple diagram of something, right? So we basically have all parts of a system. In our case, going to be UI and the APIs and logic and database. And I do something, but I need to understand if something has changed. And there's difference of where I actually access stuff in order to change my perception of how easy it is or not. So obviously I can do this. If I do an operation either on the UI or call an API or something, and I want to see, well, has data changed? I can access the database. This requires tools, understanding SQL language or whatever. It requires configuration, maybe reading logs, transaction logs are my favorite. So it is possible, but we see that like sometimes like a different skill altogether. We already talked if we're just doing things through the APIs, like a black box things, we may not have all the data. It may not be easy to get the data that we want. We may it may not even, if you're working just through the API, it may not be enough because I want to set up, I don't work on a database from scratch, so I need to fill it up with data. So I need to run APIs to fill it with data. In the former case, this would be like this. I would operate directly on the database, run SQL strings, for example, SQL queries, SQL procedures in order to fill it up with data. I need to prepare that data in advance. So this is another level of control that I need to have in order to test better. It's the same with the UI, or even less so, because UI usually doesn't expose all the information that you need in order to run it. Like if you have an API that creates a meeting and a UI has three screens that you need to fill up in order to call this API, that requires even more work. Again, more work means less testability. And usually what happens is that we need to do all three, like in order to write the test. And the more we do this, we perceive all three kinds of errors as different set skills, different efforts that we need to combine, and it's going to be harder. Again, with an asterisk, if somebody's done this before, creating the next one, it's going to be a lot easier. But for the first time, it's going to be hard, and it doesn't change the maintainability cost, because changing this kind of test, even there was only before, doesn't go down. The final thing I'm going to talk about is running things in parallel, or what happens when we want, remember I talked about reproducibility, we want to create different scenarios that one thing comes always before the second. So if I want to make sure that I want to reproduce some kind of not a race condition, like the opposite of race condition, I want to make sure that something happens first. This might be a problem. Imagine that you're either calling an API or sending messages through a queue, and it needs to be, somebody's going to pick them up, and something needs to be first. So if there's one queue, okay, maybe easier, but you don't get a guarantee that if you send something, it will actually arrive in that order. And that's a reproducibility problem. If something is, we can't trust it's going to be reproducible, we kind of perceive it as something that doesn't, it either requires a lot of effort to do that, build our own queue, or if it's not going to be that dependable, we're not going to trust it, therefore we're not going to write the test. And that's one thing. We also have this kind of thing also at the database level, right? So even if we're able to do things like sequentially at the logic level, if we want to produce something that runs according to our timeline, in the database, it's going to be even harder to do that, because how do you do that? You need to control sequences, and that's not just like who gets there first. What's the delays? What's the timeouts? Things we need to control, and when we define the test, we go to the realm of it's not possible, it's not worth it. We'd rather write tests for the things that are easier to do. So these are kinds of things that affect our perception of testability. And the more you know the patterns, the more you kind of control this. And the answer, and the question is, well, of course, well, if testability is that good, who's responsible to do it? And we kind of think about, well, it's in the code, it's in the architecture, so the developers are responsible to do it. So that is true. But like I said at the beginning, everyone will benefit from having testable code. If the system is testable, chances are we're going to test it better, more deeply, we'll know more about it, we'll have more confidence that things are working. So it has to be a collaborative effort. And in order for this to be a collaborative effort between developers and testers, work needs to be done in a certain way. For example, if you went into a sprint planning, and when you came out of sprint planning, the developers knew what they were supposed to test, and the testers would know what the developers were going to test and what they're going to give them. And the developers knew what kind of tests the testers are going to do, and therefore write or design the code in order to make that more easy, things will be better. And this is the kind of collaboration I'm talking about. We need to plan together, both developers and testers, and work together in order to facilitate this kind of testability. So sprint plans are the example for that, but that's not the only thing. Code reviews. So we kind of think about, well, developers write the code, they review the code. Yes, but they usually don't review it for testability. And if they're not part of the planning, they don't even know how the testers are going to test it. If you want tips about this, by the way, I talked about this in my talk about test design. Look it up. Going to be a link when the recording comes out. So we need our system to be applicable to tests that are going to be written, and in order to do that, I need to know as a developer what the testers are going to do. So this is where the planning comes, and at the end is the code reviews. So the developers finished their job. Did they? Well, let's check. And in order to do that, in order to make sure that it is testable enough, or in as much as we get enough ease, I would suggest testers would do some kind of code review, because they come in with their testability goggles and look and say, well, this is okay, this can be better. So collaboration is the key to do that. So to summarize, testability is important. It affects our ability to create better quality products. It starts with the code. Everybody knows how hard it is to take some bit of legacy code and patch tests on it. So we don't want that. But in order to do that, we need to think a bit differently, to change our perspective about valid designs and valid code patterns that make things more testable. So we need to be aware of how we run this code, not just us. How are we going to test this code, and how we're going to run it, how we're going to observe results, how we're going to set it up and clean it up, and how things are going to be reproducible or not, and how reliant this kind of code and the tests are going to run based on the way it's written and designed. We need both eyes, both of the developers and the testers on that, and we need collaboration in order to make sure that everybody benefits from better testability. It results in better tests and better testing, and better testing leads to better quality. That's what I wanted to share with you today. Thank you for coming here today. You can get in touch with me with all kinds of ways you can see on the screen. If you're interested in this kind of stuff, let me know, and I'll do more webinars about this. Okay, guys, thank you very much for coming. I'm shutting this down. Have a nice day. Bye-bye.